Okay, today's lesson is we want to simplify trigonometric expressions. We can make this, what up? That's because you weren't here. Shh. Okay, so our goal is to simplify trigonometric expressions, okay? And so as we look at the first one, it says, what is sine of theta times secant of theta? So you're going to learn a couple new things, but this simplifies. Kind of like if I had this statement, if I had 2x divided by 6x squared, what would that simplify to? Excellent, 1 over 3x, good job. 1 over 3x. So you know how you simplified algebraic expressions? We're going to do the same thing with trig expressions. And we're going to try to do the most basic ones, okay? So there's some really, really challenging ones. We're going to try to keep it to just kind of the most important pieces. And we're going to need a few things in order to make sense of this. First of all, we're going to need to know that tangent is the same thing as sine of theta divided by cosine of theta. And tangent is 1 over cotangent of theta. Now I want you to know that this is what's most important. Knowing that tangent and cotangent are reciprocals is important, but the most important piece is to know that tangent is sine divided by cosine. Cotangent is the reciprocal of tangent. So instead of sine divided by cosine, it's going to be cosine of theta divided by sine of theta. And cotangent is 1 over tangent of theta. Again, the second statement is true, but this is the most important part. Are we okay with that? This means cosecant. And cosecant is the reciprocal of sine. It means 1 over sine of theta. Cosecant is 1 over sine of theta. And so sine is 1 over cosecant. Although both of those are true, this is what is really important that you're going to be using. And finally, secant is 1 over cosine of theta. So cosine is 1 over secant. They are reciprocals. Although both of those are true, this one is the most important one that you'll be using. And what's really great about all 6 of these trigonometric expressions is they can all be written in terms of sine or cosine. And so the strategy today that you're going to use for simplifying these expressions is to write them in terms of sine and cosine. So I'm going to write this as sine over 1. Secant isn't written with a sine or a cosine. What did we just write down that we could replace secant with? Secant is the same as 1 over cosine. So what are we going to get when we multiply those together? What's on top? Sine of theta. And what's on the bottom? Cosine of theta. Is sine over cosine something special? Yeah, very good. It's tangent of theta. So you can see sine times secant simplifies to tangent of theta. Shouldn't feel real natural right away. Should look a little bit odd. We'll be doing many examples, kind of help it sink in better. Give it some time and you should be fine. How about cotangent? How can I rewrite that? I can, but the objective is, and so thank you for saying that, 1 over tangent, does that have a sine or a cosine in it? No. So I want to use this because it has sine and cosine in it. See the difference? We want to use the one that has sine and cosine. So we're going to write as cosine over sine. The second part, sine, it's written in terms of sine and cosine. So I don't want to switch it. Some people might say, well, switch it to cosecant. I don't want to use this. I only want to use these pieces right here. So I'm just going to write it as sine of theta over 1. Does anybody see what's going to happen? What's going to cancel out? Sine will cancel. And you're just left with cosine. Excellent. We're going to skip letter C. We're going to move to letter D. How can I rewrite cotangent of theta? Cosine over sine times what? One over cosine. What's going to happen? The cosines will cancel, leaving you with what? 1 over sine. Am I done, or is 1 over sine something special? It is something special. What is it? As you can see, 1 over sine is cosecant. So I'll write this as cosecant of theta. I would like you to try letter E on your own. Go. Try letter E on your own. Rewrote tangent as sine over cosine. And cosecant, I'll write as 1 over sine. Notice that those cancel. And I get 1 over cosine. What is 1 over cosine? It is secant. Good. Not too bad, is it? We'll finish off a couple examples here. This is something you're very capable of doing. And you're referencing new trig identities. This next one, I have 3 pieces. No worries, I can rewrite secant as what? 1 over cosine times 1 over sine times cosine over sine. Excellent. True or false? Everything cancels out. False. What cancels? Cosines cancel. So you have 1 on the top, and what do you have on the bottom? Sine squared. Sine times sine is sine squared. The way we write that is sine squared of theta. You've seen that this is similar to what we wrote before. If it was just 1 over sine, what would you write the answer as? 1 over sine is the same as cosecant, so 1 over sine squared is cosecant squared of theta. Excellent work. What's different about letter G? You're dividing. Yep. So I'll write tangent as sine over cosine. And then what about secant? How do I rewrite that? 1 over cosine. I don't ever divide fractions. What do you do instead? So I will multiply by the reciprocal, which would be cosine over 1. What happens? Cosines cancel, leaving me with sine of theta. You can try letter H on your own. Go. You guys are catching on just fine. 1 over sine of theta divided by cosine of theta over sine of theta. I saw a lot of people multiply by the reciprocal. Sines canceled. 1 over cosine gave me secant of theta. Good work. The sines canceled, leaving me with 1 over cosine. And 1 over cosine is the same as secant. Thank you. Let's try it. This next one, sine times secant. Let's deal with the top first. Sine times secant. How do we rewrite that? Sine over 1. Excellent, Kenzie. Times 1 over cosine. Okay. The goal is to rewrite it so that it has a sine or a cosine in it. So if you take sine and you rewrite it as 1 over cosecant, that takes away the sine or cosine. See what I'm saying? Leave it like that. Don't write it like that. Get my point? Okay. Then we'll have to talk individually. I don't know how to make it any clearer. If it's sine or cosine, don't change it. Don't change something just for the sake of changing it. Tangent. Does tangent, like as you read tangent, does it have a sine or cosine in it right now? No. No, so change it so that it does. Yeah. What do you want to change it to? What is tangent? Sine over cosine. So what are you going to get in the top? What do you have in the bottom? Sine over cosine divided by sine over cosine is just going to give you 1. In the top you have sine over cosine. In the bottom you have sine over cosine. And if you ever take something divided by itself, you get 1. Last 2. I'll rewrite the top. Tangent I rewrite as sine of theta over cosine of theta. Do I rewrite cosine? No. Do I rewrite cosecant? Yes. To what? 1 over sine. True or false? I have the same thing on the top as I do on the bottom. You don't, do you? And so if we take sine of theta over cosine of theta on the top, and on the bottom you have cosine of theta over sine of theta. They look the same, but they're not. They're switched. And I don't divide. Instead, I multiply by the reciprocal. So I'm going to multiply by sine over cosine. So does anything cancel? So what do you get in the top? Sine squared. What do you get in the bottom? Cosine squared. So you get sine squared over cosine squared. What's sine over cosine? Tangent. So what do you think sine squared over cosine squared is? Tangent squared. Last example. Sine squared over 1 times what? Cosine of theta over sine of theta? Times what? 1 over sine. Does anything cancel? Yeah, because in the top you have a sine squared, and in the bottom you're going to have a sine squared, right? So that cancels with both of those. What are we left with? Just cosine. So simplifying trigonometric expressions We can look at all sorts of different levels of kind of problems. This is the most fundamental one where we change things in terms of sine and cosine and we simplify, and that's what your homework is going to be on. So if you look at your homework right in front of you, just the front page, that's all you're looking at right now. I bet many of you could actually finish the whole thing.